So, good afternoon and good morning and welcome to this lecture of electronics. And I guess myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics. And in the last classes, we were studying some of the features of 8051 and we have almost completed say pin diagram and everything. Today, we are continuing with the same procedure. Just we will revise some portion of it. So in the last lectures, we have studied some ports, right? So I just need to brush it out. What were the ports that we have used? So these were some of the terminals that we were using. That was the reset terminal. Reset pin is an input pin, right? And I just need to show you some, after the reset, what happens on that in the microcontroller itself. So the program counter is reset to 00, and then DPTR also reset to 00. Accumulator, program status word, stack pointer, as well as register B, port 0 to port 3 means all the ports will have the output equal to FF. So as we push the reset button, it all happens over there. Then we have this terminal, which we call it as external access. And external access means which the microcontroller gives access to the external memory and data in that case. So those are the pins. Then we have program store enable is an output pin. So these all we have almost completed, and this is what I need to show you. So these are the input output ports that we need to study and which are very important as far as microcontrollers are concerned. So they are basically being to give the output data and take the input data, right? So that is the main important function of the microcontroller. That those are ports, and if somebody can share, madam, scale आहे का? स्केल मोठी मोठी आपल्याकडे इथेच तर ठेवली होती कुठेतरी. अच्छा, सो येस, आता ठीक आहे का? दिसतं मधात. ओके, सो थँक यू मॅम. So yes, input output ports. So we are having in all four ports, which start from say P0, P0.0 to P0.7. That is the first port that we are having. And why we are studying this? Because microcontroller is actually meant to give the input and take the input and give the output, right? So they have been programmed for a specific purpose, and for that we require these ports. So these ports are very important. So P0.0 to P0.7, this is the first port. We are having eight pins for that, and they give parallel output, as well as they can be multiplexed when they are being used to program the microcontroller, right? To write a program or to feed the program in the microcontroller, we use this same pins as AD0 to AD7, means they can be used as address as well as they can be used as the data lines, right? So AD0 to AD7, they are multiplexed again, but they are only used when they are being we are being writing a program inside the microcontroller. Similarly, we are having this port 2. So it starts from P2.0 to P2.7, and it gives you A8 to A15, means higher order address of the memory can be given by this port, right? So this is again used when we are programming it. So when we programming it, this is used as the upper order higher address bus, right? So which starts from A8 to A50. Or and otherwise, when we use it after feeding a program or after storing a program inside the microcontroller, we can use this as a port, right? So we can use it as an output port, or we can use it as an input port as per the program. Then we have the another port, that is P1.0 to P1.7. Now it is being used specifically as an input and output port. So we can use it for just giving the data. Now the another port we are having is P3.0 to P3.7. They are also being used for other purposes when they are being given the data. So we are having a receiving ping. So we can receive the data as well as we can transmit the data. These are serial pins, right? So the data can be given serially and the data can be taken serially inside the microcontroller, right? Then we are having this. These are the some of the interrupts that we are having, and then we are having write and read. So whether the microcontroller needs to write a program or whether the microcontroller is reading a program, that is being determined by these two pins, P3.6, P3.7. Again, what I mean to tell you is these pins which are being used doubly when we are programming it, these pins are working like this. Whereas when we have filled the program, then they are being using as a plain ports, right? So I guess this much I need to tell you about the ports. Then these are some of the explanations for these ports P1 and P2. Then these are the port 0 that we are having, and okay, it won't work like, yeah. So port 0 is also designated as AD0 to AD7. That is what I have told you. When connecting an 8051 to an external memory port, 0 provides port 0 provides both address and data, right? So we can use address data bus. I have already told you. And this is the address latch enable. That is one of the pins where we can use it as address or whether we can use it as a data, right? So this pin is going to tell you whether it is being used as data. When ALE or address latch enable is 0, it provides data, and when it is say, yeah, when it is high, it is using as the address, lower order address. Okay, then port 1 and port 2, they can be combined like this. Port 1 is specifically used for the ports, right? Input output port with no both P1 and P2 are used as simple input output ports, but in the same case, we are using it for, say, with external memory connections. Port 2 must be used along with P0 to provide 16-bit address. As I've told you that this can be used as the address bus also, up lower order address bus, sorry, up higher order address bus. And yeah, so P0 provides the lower 8 bits via A0 to A7, whereas P2 is used for the upper order address bus, that is 8 bits given from A8 to A15, and it can be used as input output ports also. So when programming, we are using it like address and data bus. Then port 3 can be used as input or output port simply when it has been programmed. But so yeah, port 3 has the additional function of providing some extremely important signals, which I have told you. These were say the okay, these were say receiver. So serial communication के लिए use करते, serial data लेना है, serial data देना है, right? For that we are having this receiver terminal as well as transmission. Then these are interrupts, external interrupt 0 and interrupt 1. Then these are timers T0 and T1, and read bar and write bar means we have to read the signals, read the data, or write the data. So that is being shown over there. And after that, these are some of the pin descriptions. So if you want, we can share it. These are very simple given. So today we are going to start with this topic, that is the memory organization of microcontroller. Up till now, we have studied earlier in the earlier classes. So we'll go through that. So this was the general block diagram of 8051. I have already shown you. This is inside the microcontroller chip, which is inbuilt inside it. So we are having everything, input, output, memories, and their connections, which are inbuilt inside it. This was the basic difference between the microprocessor and the microcontroller. In microprocessor, we are having just the arithmetical logical unit and some register, right? And timing and control unit, program set as well. But here in microcontroller, we are having everything inside it. So yeah, the oscillator circuit is also there. Then ports are there. So this is the block diagram. Now this is the detailed block diagram. Whenever you require this, it is also there for your ready reckoner, which is put on that flex above that. So you can see that there are some blocks which can be used. It's simple as good as say our 8085 microprocessor kit, right? So I guess we have almost completed this. These were ports, port 1, port 2, port 3, and this is port 2, this is port 0. I guess it is very faint, so it won't be able to, you won't be able to recognize. This is the arithmetic and logical unit, right? Then we are having temporary register and temporary register 2. Why we require this temporary 1 and temporary 2? because we need to add or subtract or say any arithmetic and logical operation, we require two data to be used at a time. So that data should be come first in these two temporary registers, and then they are being say operated in this unit, and then it is being given to the say the accumulator directly. So the data is stored over there. So this was the block diagram. Yeah, and this is the 8051 memory space structure. So we are having all external, internal. So we can use it external as well as that. Then we are having external access is equal to 0. Then we are using the external memory. When we are having external access equal to 1, I've shown you that pin in the pin diagram. So it uses the internal memory, right? So whenever we have say feed the program inside the microcontroller, then it is going to use the internal memory, right? Rather than the external. External memory is only used when we are putting a program inside that. So that program is there. Then this is 64 kilobyte, and this is 60 plus 4 kilobyte over there. So yeah. So this is registers which are having 128, and they are internal registers. Then we are having an external 64 kilobytes of data memory, and this is the program memory. So program memory can be either outside the microcontroller as well as it can be inside the program inside the microcontroller, right? So this is the external data memory which is being used, and this is the internal 128 and the registers as well. So this is the memory structure. Then internal RAM structure we are having. So this is direct addressing only, and this is direct and indirect addressing only. We call them as a special function registers, SFRs, and 128 byte of internal RAM. I have told you there are many registers in say microprocessor. We were having only 7 registers, whereas in over here we might have more than 128 registers over there, so that we can use those registers. Uh, yeah, so 120 byte of internal RAM, and these are special function registers over there. Then special function registers are number A, B, C, D, program counter, DPH, DPL, and we are having data pointers over there. Data pointer higher, data pointer lower. Then we are having a program counter. Again, program counter keeps the track of the next memory location, address of the next memory location, in fact. So that is there. Then we are having program status registers. Those are flags. Then stack pointer, right? Then we are having math registers. There's a register B and register A over there. Okay, and then timer and control registers. Then timer counter register, they are different. So we are using counter registers also in microprocessor. We used to have a counter program for that, right? Here itself we are having a counters that can be used. Interrupt registers are there. Then serial data registers are there. These are special function registers which we are having 80, 81, 82. Then there are names of those registers, which I guess we won't be using there. We are having accumulator, instruction pointer, instruction enable. Then I have not used that. I guess. Okay, let me share this. Mm. Okay, so is it okay? Right. So we are having this program status code. Again, we are using it as a flag, right? So flags are carry flag. Now, what is carry? Whenever there is a carry generated or a borrow generated after a aid bit of subtraction or addition, right? Then this carry flag or set or reset. Whereas auxiliary carry is the carry which is generated by addition or subtraction of a nibble. 4 बिट का एडिशन या सब्ट्रैक्शन करने के बाद बोरो या कैरी जनरेट होता है, तो तब ऑक्सिलरी कैरी सेट या रीसेट होता है. कैरी 8 बिट के एडिशन और सब्ट्रैक्शन पर जनरेट होगा, और ऑक्सिलरी कैरी 4 बिट के एडिशन या सब्ट्रैक्शन पे निबल बोलते हैं हम लोग. 4 बिट का एडिशन सब्ट्रैक्शन किया, उसमें अगर बोरो जनरेट हो रहा है या कैरी जनरेट हो रहा है, तो ये ऑक्सिलरी कैरी फ्लैग हाई होगा या लो होगा। यूजर फ्लैग है, तो यूजर फ्लैग F0 है, you can use it for any purpose. This is meant for user flag. Then this is another user flag which can be used. This is register bank select. So which bank you are going to select for register? So we are having banks of register, as we have had in say microprocessor. We were having only 7 registers. Now here we have a bank of registers. So which bank you are going to use? R0, RS1 to RS0, right? So these are the flags according to which we can use our banks. And yeah, then 8051 instructions that affects flags. Now these are some of the instructions. We need to study these instructions in depth because we are using those instructions. So we are having this add. Now these flags had been affected. So carry, auxiliary carry, and overflow, right? So whenever we are having a number which is extending, or which we are having a carry or say borrow, then this add instruction is there. Means I mean to say, if you have a general meaning over it, so all the arithmetic and logical instructions are going to affect those flags, right? Transfer or copy instructions are not going to affect those flags, right? Simple, in simple words. So all these are division and then multiplication we are having. Now we are extended version of those instructions. In microprocessor we were not having these instructions, multiplication and division. Now here we are having this division and multiplication. Clear, this is ending, oring, and this moving, and then carry. These are some of the instructions which affects those flags: overflow and auxiliary carry, division or multiplication, subtract, addition with carry, add. So these all instructions affects those the flags, and mainly carry, overflow, and the auxiliary carry. Right. So yes, then 120 bytes, 128 byte RAM is there, which is random access memory. There are 128 bytes of RAM in 8051. Assigned address is from 00 to 7FH. So this is the address of that. 128 bytes are divided into three different groups as follows. A total of 32 bytes from location 00 to 1FH hex are set aside for register bank. तो RS0, RS1 जो अभी हम लोगों ने देखा था, उसको असाइन करने के लिए वी आर हैविंग दिस 32 बाइट्स विच स्टार्ट फ्रॉम 00 टू 1F, राइट? सो ये है. Then these are those: register bank 3, register bank 2, register bank 1, and register bank 0. Then a total of 16 bytes from locations 20H to 2FH are set aside for bit addressable read write memory. So whether we are reading the data or we are writing the data. अब राइट कब करेंगे हम लोग डेटा? जब हम लोग उसको प्रोग्राम कर लेंगे और डेटा आउटपुट करेंगे तब की बात, right? For some instance, if I need to have some results of say some data acquisition system, अगर मुझे एक सेंसर इंस्ट्रूमेंटेशन सिस्टम लगाया है, उसके लिए मैंने माइक्रो कंट्रोलर को प्रोग्राम किया है, और कुछ देर के बाद आई नीड कि आई हैव टू टेक प्रिंट आउट्स ऑफ दोज रिजल्ट, राइट? जैसे पेशेंट मॉनिटरिंग सिस्टम रहता है, तो पेशेंट मॉनिटरिंग में ईसीजी, टेम्परेचर, ब्लड प्रेशर, शुगर, ग्लूकोज, ये जितने भी है पैरामीटर, इनका मुझे कभी कभी प्रिंट आउट लगता है. तो व्हाट आई विल डू, आई विल आउटपुट द डेटा. ये डेटा मुझे आउट में आना चाहिए, राइट? तो इन दैट केस आई विल रिक्वायर राइट मेमोरी. रीड मेमोरी मतलब वो डेटा पहले तो अंदर लेना है और उसको क्या करना है, उसको प्रोसेस करके एक लेमन अंडरस्टैंडेबल फॉर्मेट में लाकर दिखाना. That is reading the data. And writing a data means writing in the printer also is writing a data, or putting it in a memory is also writing a data in that case, right? So that for that 16 bytes from location 20H to 2FH are being dedicated for those purpose. Then we have 80 bytes from location 30H to 7FH are used for read and write storage called scratch pad, राइट? तो ये स्क्रैच पैड मेमोरी जो होती है, ये सिर्फ रीड और राइट के लिए होती है. अब डेटा लिखना है और क्या कहते हैं, रीड करना है और राइट करना है. एक्चुअली व्हेन वी राइट अ प्रोग्राम, एवरी टाइम एक बार प्रोग्राम किया, जैसा हम लोगों ने एक प्रोग्राम लास्ट टाइम किया था, वो प्रोग्राम में क्या किया था हमने, वो प्रोग्राम हम लोगों ने उस पर फीड कर दिया, उस पर लिख लिया। राइट नाउ इफ आई नीड कि मैं उसके ऊपर ओवरराइट करना चाहता हूँ, उस दूसरा प्रोग्राम फीड करना चाहता हूँ, तो क्या होगा, वो जो पहला प्रोग्राम था वो एलिमिनेट हो जाएगा, वो पूरा का पूरा रब हो जाएगा, और उसके बाद हम लोग उसके ऊपर दूसरा लिख सकते हैं। सो दैट इज द मीनिंग ऑफ दिस क्रैश पैड। Okay, and this is the general purpose area where we can write a program. So any sort of program can be written. Then we are having this is 8051 RAM with addresses. So that whatever I have told you in the last slide is being given over here. So these are the bank, then bit addressable RAM, scratchpad RAM is shown over here. Okay. Then 8051 register bank structure. So R0, R1, R2, R3, R4 and R5 ये इतने बैंक्स है हमारे पास रजिस्टर्स के which can be used. So if you need to use those, you have to write accordingly the आपका जो वो प्रोग्राम स्टेटस वर्ड है उस पर आपको देना पड़ेगा कि आप कौन सा बैंक यूज करने वाले हो. तो R0, R1, R2, R3, R4, R5 एंड R6 इनका बैंक जीरो के उतने ही है, बैंक वन, बैंक टू और बैंक थ्री के भी उतने. Okay, so register bank with addresses. So these are addresses of that 00 to 07H, then 08 to 0FH, 10 to 1H, 17H, and 18 to 1FH. Hex में. So those are their address. Those are their addresses of bank. Okay, so this is the programming model. I guess this much is enough for today. We can continue in the next lecture. तो प्रोग्रामिंग मॉडल आज यहाँ तक के है, हमको सिर्फ मेमोरी का आज ये करना था. तो वी हैव ट्राइड टू लर्न अबाउट द प्रोग्राम मेमोरीज ऑफ 8051. तो ये पूरा मेमोरी स्पेस के बारे में ही बताया हुआ है आपको इसमें. मेमोरी स्पेस, देन 8051 स्ट्रक्चर, इंटरनल रैम, स्पेशल फंक्शन रजिस्टर्स, देन स्पेशल फंक्शन रजिस्टर्स कैसे बना है वो बताया हुआ है. राइट, फिर इसका स्पेशल फंक्शन रजिस्टर्स के नाम है, ये कौन से है. प्रोग्राम स्टेटस वर्ड, कैरी, ऑक्सिलरी कैरी, यूजर फ्लैग 1, यूजर फ्लैग 0, देन ओवरफ्लो फ्लैग, पैरिटी फ्लैग. पैरिटी फ्लैग आई गेस यू अंडरस्टैंड. पैरिटी मतलब 8 बिट में कितने नंबर ऑफ वंस है, दैट इज कॉल्ड एज अ पैरिटी. अगर मान लो 8 में से 4 वन है तो वी कॉल इट एज अ इवन पैरिटी. राइट, और अगर 3 है तो वी कॉल इट एज अ ऑड पैरिटी. राइट, सो दैट इज कॉल्ड एज अ पैरिटी. मतलब हाउ मेनी नंबर ऑफ वंस आर देयर इन अ से दैट बाइट, 1 बाइट डेटा. तो ये बाइनरी में कैसे लिखते हैं हम लोग, 00011 ऐसा लिखते हैं ना. तो इसमें कितने नंबर ऑफ वंस है या कितने नंबर ऑफ जीरोस है. इफ देयर आर इवन नंबर ऑफ वंस एंड जीरोस देन वी कॉल इट एज even parity, and we call it as the odd number of ones and zeros, we call it as the odd parity. So that is the parity. Right, overflow means if it is extending more than the required, ff से ऊपर जा रहा है, right, data, so that goes in the overflow. सिंपल, मतलब हमारे जो ये है वो वैसे. रिजल्ट बैंक सिलेक्ट, so which bank you are supposed to select should also be mentioned over there. Then these are some of the instructions which are going to affect the flags. यूजर फ्लैग इज मीन फॉर यूजर, मतलब यू कैन डिसाइड कि आपको क्या करना है. हाँ, अकॉर्डिंगली आपको किस चीज के लिए, पर्पस के लिए वो फ्लैग चाहिए, दैट कैन बी प्रोग्राम अकॉर्डिंगली. राइट, तो वो यूजर को दिया हुआ है कि योर डिस्क्रिप्शन आपको क्या चाहिए. आपको सब्ट्रैक्शन के लिए चाहिए, आपको एडिशन के लिए चाहिए, या जब कभी भी सब्ट्रैक्शन होगा तो लेट मी नो. ऐसा अगर मैं चाहता हूँ, जब कभी मैं मल्टीप्लीकेशन होगा आई शुड नो कि मल्टीप्लीकेशन हुआ है ना. तो उसके लिए मैं यूजर फ्लैग को वो डिफाइन कर सकता हूँ, तो वो उनके लिए दिए हुए. तो दीज आर सम ऑफ द इंस्ट्रक्शंस व्हिच आर अफेक्टेड बाय दैट. एंड दिस इज रैम, internal RAM, which is 32 bytes is given for register bank, then bit addressable area, then scratchpad, general purpose area where we can read or write the data, always use. And this is that structure, these are the address lines, address specifications of those registers. And these are the bank structures. Then these are again the bank structures with addresses. And this is the programming model, that how you are going to write a program. इज इट क्लियर? ठीक है अभी तक के कोई प्रॉब्लम? तो yes, thank you very much for joining this lecture. I will be uploading more videos of microcontroller on my YouTube channel. Please go through my YouTube channel. Thank you, and like, share, and subscribe my channel. Thank you. Stay home, stay safe, take care. Good day.